All right, so today we are going to continue on in Tech Math with section 3.5, and we're going to be talking today about time, current, and some other units that are kind of associated. So let's go ahead and just jump right over to the notes. And really quick, what I want to do is I want to draw your attention to just some of the pretty common units of conversion here. So I think we're all pretty familiar with time. We deal with it on a daily basis, right? So 1 minute, 60 seconds, an hour would be 60 minutes, a day is 24 hours, and then generally a year is 365 days in a quarter. And that little quarter actually has to do entirely with our leap years. So if you think about the month of February, every 4 years we get an extra day. That's where that comes from. So just a thought. There's other units, smaller units of time. So we have milliseconds, microseconds, nanoseconds, and the smallest of all, which would be a picosecond. So for time, again, these are kind of like the more uncommon units of time that we measure things in. I don't know if anyone's ever watched videos from like the slow-mo guys, but they always will look at things in terms of like milliseconds and microseconds, and just how it's really actually pretty cool, just all the different things that they do, like firing a bullet or exploding, whatever it might be, just to see how all of these things kind of work in such slow frames of time. It's actually pretty cool. So if you have a chance, this is kind of my shameless plug for those guys, but go ahead and do a YouTube search for the slow-mo guys, and it's pretty cool, all the stuff that they do. For units of current, there's a few different ones that we're going to be dealing with in particular, but the basic unit that's probably the most common is an amp. And amps are actually a pretty large in terms of units, so generally we'll measure things in terms of milliamps or microamps. In fact, milliamp is mostly what I've seen. It's a pretty common unit that's used in a lot of different current applications. Okay, another common unit is watts. So if you think about like the wattage of a light bulb, right? Nowadays, most light bulbs that we interact with or deal with are pretty much like LEDs. And so generally they're measured in terms of lumens, which is a light output, but they have generally a associated wattage for people who are used to using incandescent light bulbs. And so again, it's kind of another unit of measure for energy, I should say. Okay. Milliwatts, kilowatts, megawatts. If anyone's ever seen Back to the Future, there is no such thing as a gigawatt. Unfortunately, there are gigawatts, but there are not gigawatts. So, something else. A couple of other units used in electronics is volts. Ohms is generally used for resistance. This symbol that you see here is actually it's the unit, it's omega. It's a Greek letter. We have hertz, which is frequency. Oftentimes, radio frequencies are used for this. And surprisingly, radio frequencies are just another form of measure of energy. So the amount of energy that's produced by the size of the waveform of a radio wave. So we use that for frequency. These other ones are way less common. Farad, Henry, and Coulomb. Honestly, I've never really used them a whole lot. So for the most part, you're probably going to be just sticking with what we have up above if you have to make any kind of conversion or things like that. So, all right, let's go ahead and jump over into our notes, and we'll work on a couple of different problems here. Let me go ahead and get switched out to my whiteboard. Okay, and we'll switch over. There we go. All right, so it's very similar. Making a lot of conversions specifically is going to be dealing with the SI system, so the metric system. And so in particular, the first question that we're going to be dealing with here today is specifically just going to be dealing with the time intervals, okay? So if you look, the first question is to change 1 hour, 25 minutes, and 16 seconds just to seconds, okay? Now, normally, I'm kind of a person who likes writing out my units of measure. Like, for example, the way that I've written the units here, so the hour, the minute, and the seconds is the common kind of standard way of writing it. I am a person who kind of, I'll write out like SEC, right? For the, not that I'm like a football fan or anything, but I'll write out SEC for seconds just because that's like what I've commonly done in the past. It doesn't necessarily mean it's correct, but I just want to point that out, that if I do it today, it's because it's something that I've just been used to doing for so long. So because we have all of these units here, what we need to do is we need to take each individual piece and break them down and then just add them all up at the tail end. So I've got 1 hour, and I know right now, right off the bat, that 1 hour is the same thing as 60 minutes. And then I have to convert this minutes into seconds as well. And so one thing that we can do is multiply that by the conversion unit. So I've got 1 minute here and 60 seconds right here. We know, see, I just did it right there, the SEC. There we go. And so now what we can do is we've got the minutes are the units that are going to cancel out right there. And as a result, I've got 60 times 60, which is going to be 3,600 seconds. And that makes sense, actually. If you think about it, 60 seconds every minute, there's 60 minutes in an hour. You take those two units together, you multiply them out, and you get 3,600. So that's how many seconds are in an hour. Now we have to do the same thing with the minutes. So I've got 25 minutes. And I'm going to use the same process I did in the previous one. I'm going to multiply this by 60 seconds over 1 minute. And I'm going to get a specific value as a result. So 25 times 60, got my notes here. This is going to be 1,500 seconds. Okay. And then lastly, I've just got 16 seconds, right? And that's just equal to 16 seconds. Duh. Don't really have to do too much. So now if I'm converting this entire thing into seconds, the way that I'm approaching the problem, as you can probably see, is that I'm breaking it up into kind of a series of like smaller problems, and then I'm combining them all on the end. And that's really what we do. So I'll have my 1 hour, 25 minutes, 16 seconds is really going to be 3,600 seconds plus 1,500 seconds plus 16 seconds. And as a result, after I do all of the adding, I'm going to end up getting 5,116 seconds. And that's how long an hour and 25 minutes and 16 seconds is. Okay, so that's going to be my final answer. All right, let's go ahead and jump on to the next problem. Okay, again, this one's going to be pretty similar to what we've already done. So this one, again, if you want to look at the textbook, I'll just give you the numbers. This was 31, and this previous one was 26. So you can kind of see that I'm doing examples that are similar to what's in the back of the textbook or the back of the section. And these are similar questions to what's on your homework assignments as well. So I just want to point that out. So in this one, this next one, we're going to change 1,500 kilohertz to megahertz, Hz, okay? So the important thing to remember is that for mega and kilo, there's a huge difference. And that difference, I shouldn't say huge. I should say there's a difference in terms of 1,000. So in other words, this is kind of a little note you can make. So note, mega is 1,000 times bigger than kilo. Okay. So if that's the case, then 1,500 kilohertz. I'm going to do my unit conversion here. I know that 1 megahertz is going to be the same thing as 1,000 kilohertz because of that difference, the conversion factor. And as a result, what you see here is that the kilohertz are going to cancel each other out, and I'm going to be left with 1,500 divided by 1,000. This is going to be megahertz as a result. And all you have to do, if you want, the easy way to simplify this stuff would just be to cross out the zeros, and then you get 15 over 10, which is the same thing as 3 halves, or 1.5 megahertz. Okay. The other way to think about it is 1,500 divided by 1,000. If I have my decimal, I'm going to move it 3 places to the left. 1, 2, 3 right there. And so you can also do it that way as well. Either way works perfectly fine, makes no difference. And that's going to be my solution in this problem. Sorry for my middle school handwriting, though. So I know I don't have the cleanest handwriting, but I know for a fact I certainly don't have the sloppiest. If anyone in here has ever seen or worked as a pharmacy tech, which I have, most doctors nowadays, they'll hand in their prescriptions via like computer, because I think the biggest complaint for pharmacy techs was that they could never read doctors' handwriting, and it's true. Like, doctors have absolutely the worst handwriting in the world. So I don't think I'm as bad as them, but maybe I am. Who knows? What do I know? In any case, that's all I have for today. If you have any questions, again, don't hesitate to reach out. Let me know, and I will be seeing you on the other side.